Welcome to another deep dive, and this time we're tackling those AI powerhouses that are changing how we interact with information. Large language models, or LLMs for short.
LLMs, yeah, they're everywhere these days.
It feels like every day there's a new breakthrough or a new application.
Right.
So if you've got a whole stack of research notes here about how they actually work, the challenges developers are facing, and some seriously cool applications that are already out there.
It's moving so fast, it's hard to keep up with everything.
Exactly. So think of this deep dive as your cheat sheet to understanding LLMs.
Okay, sounds good.
What are the big breakthroughs? What are the limitations?
Yeah.
And, the big question, how can businesses actually use this technology? Like, what's the practical side of all that?
Yeah, the practical side is key. Because we can talk about the theory all day, but if businesses can't actually apply it, then it's not really that useful, right?
Exactly. So let's jump in. The research really points to 2017 as a pivotal year. Like something happened then that kind of set the stage for where we are now.
Right. Well, 2017 saw the introduction of the transformer architecture, and that was a huge breakthrough in AI. It really enabled a major leap forward. You see, before transformers came along, language models had to process text sequentially, word by word.
Oh, well. So it's like reading a sentence one word at a time.
Exactly. And that's pretty inefficient, But the transformer changed all that by enabling parallel processing.
Parallel processing. So meaning it can analyze like whole chunks of text at the same time?
Exactly. That meant faster training, the ability to handle way larger data sets, and ultimately, more powerful, more sophisticated LLMs.
Okay, so that makes sense. This transformer architecture, it basically laid the groundwork for what we see today, right? Like, you've got GPT-3, you've got PaLM, you've got Megatron Turing NLG.
Yep, those are the big names.
And they all have billions, even trillions of parameters.
Right.
Okay, but I got to ask, what exactly are these parameters? And why are they such a big deal?
It's a good question. Think of an LLM as like this massive network of nodes, right? Each node represents like a bit of knowledge or some kind of linguistic pattern.
Okay, so like connections in the brain almost.
Yeah. And parameters are the numerical values that define the strength of those connections. So they basically control how the model processes and generates language.
Oh, I see.
And the more parameters an LLM has, the more nuanced and complex its understanding of language becomes.
Okay, so it's kind of like having a bigger vocabulary and a deeper understanding of grammar.
Exactly.
In context.
Yep, you got it. It's not just about size, it's
Yeah.
really about the complexity and depth of the model's understanding of language.
Got it. And that's where these different LLM architectures come into play,
Ah.
right? Because there's not just one way to build these things.
Right. There are a few different approaches, each with its own strengths and weaknesses.
Yeah, the research dives into three main approaches, and I love how they use analogies to make it easier to grasp. Let's start with auto-encoding models, like BERT.
Oh, BERT, yeah.
The research calls them the expert readers of the LLM world.
That's a good analogy. They're all about understanding, context and the relationships within text.
Oh, what?
So they excel at things like sentiment analysis, like figuring out if a movie review is positive or negative, or pulling out specific answers from a long document.
So for a company that has to deal with, like, tons of customer reviews, this could be a game changer, right?
Yeah, exactly. They could use an auto-encoding model to quickly identify key themes and sentiment.
Okay, so it's like instant market research.
Yeah, giving them actionable insights to improve their products or services. It's powerful stuff.
That's really powerful. But what about businesses that need to actually generate text?
Yeah, that's a different ballgame.
Like, marketing copy or even code.
Right.
That's where the autoregressive models come in, right?
Exactly. Those are the writers of the LLM world.
Writers.
Like GPT-3, for example. They're designed to predict the next word in a sequence. So they're really good at generating text. You can think of them as like super sophisticated autocomplete systems.
Okay, so they can basically write anything.
Pretty much. Social media posts, product descriptions, even lines of code.
Wow, that's pretty incredible. So a marketing agency could use this to generate like taglines for their clients, or a software company could use it to generate code snippets.
Exactly. Saves their developers time and effort.
That's impressive. But what about tasks that require both? Like understanding and generating text?
Ah, yeah, that's where things get even more interesting.
Like translation or summarizing a really complex document.
Right.
That's where encoder-decoder models come in, right?
You got it. Those are like the hybrid models. They combine the strengths of both auto-encoding and auto-regressive models.
Okay, so they can do it all.
Pretty much. They have an encoder that reads and understands the input text, and then a decoder that generates the output.
Oh, that's pretty slick.
It's a powerful combination. Makes them ideal for tasks where you need to transform text from one form to another.
So a company that needs to translate its website into, like, a bunch of different languages
Exactly.
use an encoder-decoder model to do that.
Yeah, they could use it to ensure accuracy and consistency across different languages. Or even, like, a legal team could use it to summarize those really long contracts.
So they wouldn't have to, like, wade through pages of legal jargon.
Exactly. They could just get the key terms and clauses, right up front.
Wow, that's amazing. So we've got these different types of LLMs, each with its own strengths.
Right.
But here's where it gets even more interesting, right? We can actually take these pre-trained models and fine-tune them
Yes.
to perform even better on specific tasks or in specific domains.
Fine-tuning is key. It's like taking a general-purpose athlete and then giving them a specialized coach to train them for a specific event.
Okay, so we're taking this LLM and giving it extra training to make it even better.
Exactly. We train it further on a data set that's, relevant to the task or domain we're targeting.
So a healthcare company could fine-tune an LLM specifically on medical texts and research papers, making it an expert in that area.
Yeah, exactly. It could then analyze patient records, identify potential diagnoses, or even help with drug discovery. It's really incredible.
That is incredible. But fine-tuning these massive models, that must be really computationally expensive, right?
It can be, yeah. It takes a lot of time and resources.
And that's where this technique called parameter-efficient fine-tuning comes in, right? PEFT.
Yes, PEFT is a game changer. See, traditional fine-tuning often involves updating all the parameters of an LLM, which, as you said, can be incredibly resource-intensive.
Yeah, so PEFT is more targeted.
Exactly. PEFT takes a more focused approach. It updates only a small subset of parameters while freezing the rest.
Okay, so it's like fine-tuning with a scalpel instead of a sledgehammer.
Yeah, that's a good analogy. It drastically reduces the computational cost and memory requirements, so fine-tuning becomes much faster and more accessible.
That makes a lot of sense. And the research mentions a few specific PEFT techniques. One that caught my eye was LoRA. That's low-rank adaptation, right?
Yes, LoRA is a really clever technique. It uses low-rank matrices to update the model's weights during fine-tuning. So it basically injects these trainable rank decomposition matrices into each layer of the transformer architecture.
Okay, so what does that actually do?
Well, it significantly reduces the number of parameters that need to be updated, making it incredibly efficient. LoRA it's really efficient and it scales really well.
So it's like a shortcut to get the same results with less computational effort.
Yeah, pretty much.
That's amazing. And the research highlights how versatile LoRA is. It mentions, like, extending the context window of LLMs.
Yes. And even visual instruction tuning, which is really exciting.
Okay, so can you break those down a bit further for us? Like, what does extending the context window even mean?
So the context window is like the LLM's working memory, right? It determines how much information the model can keep in mind, so to speak, while it's processing text.
Okay, so if it's got a limited context window, it's kind of like trying to understand a story when you can only remember the last couple of sentences.
Exactly. You'd miss important details and connections. And similarly, LLMs with limited context windows, they struggle with long documents and, having extended conversations.
They forget what was said earlier.
Yeah, exactly. Or they misinterpret information because they just don't have enough context.
Okay, so that's a big deal.
It is. And what LoRA does is it helps extend that context window without making the model much bigger.
So it can hold more information, make more informed decisions.
Precisely. And that opens up so many possibilities for businesses.
Really? Like what?
Well, they could use LLMs to analyze longer documents, understand more complex narratives, or even engage in more nuanced conversations with customers.
That's a huge advancement.
Yeah.
And what about visual instruction tuning? What does that even involve?
So that's all about getting LLMs to understand and respond to images, not just text.
Whoa, that's like next level AI.
It is. It's a big step towards creating, more versatile and human-like AI systems. And LoRA is key here because it allows us to fine-tune LLMs on massive data sets of both images and text.
So they're learning the connections between what they see and what they read.
Exactly.
That's wild. So like a fashion retailer could use this to analyze customer photos and recommend outfits.
Yeah, or a healthcare provider could use it to analyze medical images and give a preliminary diagnosis.
Right.
Laura is making these, once futuristic applications a reality.
This is really remarkable. It feels like we're just scratching the surface of what's possible with LLMs.
I think so too. And as we, continue to explore LoRa and other PFT methods, we're bound to see even more innovative and transformative applications popping up everywhere.
This is all incredibly exciting. But before we move on to the challenges in LLM development, which I know we need to talk about.
Yeah, there are definitely challenges.
I'm curious about something. You mentioned that LoRa can be used to extend the context window of LLMs. But what are the limits of the context window in the first place? Like, why is that even an issue?
That's a great question. The context window is kind of like the LLM's working memory. It determines how much information the model can keep in mind while it's processing text.
So are you saying that if an LLM has a small context window, it's like trying to understand a story when you can only remember the last few sentences?
Exactly. You'd miss those crucial details, the connections. And the same thing happens with LLMs. If they have a limited context window, they struggle to understand long documents or, engage in those really long conversations. They might forget earlier parts of the conversation or even misinterpret information because they just don't have the full context.
Okay, so extending the context window, that's like giving the LLM a better memory,
Right.
right? Allowing it to hold more information and make those more informed decisions.
Exactly. That's a great way to put it.
Makes perfect sense. But as we kind of push the boundaries of what LLMs can do, what are some of the challenges that developers are running into? The research here mentions several key areas.
Yeah, well, one of the biggest challenges is just the sheer size of these models.
Right. We're talking about billions, even trillions of parameters.
Yeah, it's mind-boggling, isn't it? Training those massive models requires enormous amounts of data and computational power. It can be incredibly expensive and time-consuming.
Yeah, I can imagine.
It's kind of like trying to build a skyscraper using only hand tools. You need the right equipment and a huge workforce to handle a project of that scale.
So it's not enough to just have the right algorithms.
No.
You need the infrastructure and the resources to support these massive models,
Exactly.
which I imagine also raises concerns about accessibility, right?
Absolutely.
If only a handful of companies with vast resources can actually develop and deploy these models, doesn't that create a kind of AI monopoly?
That's a valid concern, and it's one that the AI community is actively trying to address. There's a growing movement towards making LLMs more accessible, more efficient, so that, a wider range of users and organizations can benefit from this technology.
That makes sense.
And that includes developing new compression techniques that can reduce the size of these models without sacrificing performance.
Okay, interesting.
And also exploring those more efficient training methods that require less computational power.
The research mentions two specific compression techniques, pruning and quantization.
Oh, yeah. Those are important ones.
Can you break those down for us a little bit? Like, how do those work, and why are they so crucial for the future of LLMs?
Sure. So pruning is kind of like decluttering a room. You get rid of all those unnecessary items to create more space, and make things more organized.
Okay, so we're getting rid of the clutter.
Right. So in the context of LLMs, pruning involves removing less critical or redundant parameters from the model. This makes it leaner and more efficient without sacrificing too much performance. It reduces the model's size, making it faster to run and requiring less memory.
So it's like streamlining the LLM, stripping away all the excess so it can run more smoothly. What about quantization?
Quantization is like taking a high-resolution image and converting it to a lower-resolution format.
Oh, okay.
You reduce the file size, but you don't lose the essential details. So, in LLMs, quantization reduces the precision of the numerical values used to represent the model's weights and activations. So we're basically using fewer bits to represent the same information. This shrinks the model's memory footprint without a huge impact on its accuracy.
Okay, so pruning is about removing unnecessary elements, while quantization is about representing the essential elements more efficiently.
Exactly.
It's a two-pronged approach to making these LLMs more compact and accessible.
It is.
And these advancements are crucial for really democratizing access to AI, right?
Absolutely.
Enabling smaller businesses, researchers, even individuals to leverage the power of LLMs without needing those massive supercomputers.
That's the goal.
That's really exciting. But as we scale up and streamline these LLMs, what are some of the ongoing challenges in their actual development?
Well, one of the key challenges is making sure that LLMs can handle an ever-expanding universe of information. As these models grow larger and more complex, they need to be able to process longer documents, understand those really intricate narratives, and even learn from multiple modalities like text, images, and videos. And that's a complex task that requires constant research and innovation.
So it's not just about making them bigger, it's about making them smarter.
Exactly. More adaptable to the growing complexity of all the data we're generating.
So where are researchers focusing their efforts? Like, what are the specific areas they're working on to address these challenges?
One area of intense focus is continual learning. You see, one of the limitations of traditional fine-tuning is that when you adapt an LLM to a new task, it can sometimes forget what it learned previously.
Oh, right, like it overwrites the old information.
Yeah, it's called catastrophic forgetting.
Mm.
And continual learning aims to solve this by developing techniques that allow LLMs to learn new tasks without losing their previous knowledge.
So it's like giving an LLM a photographic memory.
That's a good way to think about it. It allows it to build upon its existing knowledge base without those frustrating memory lapses.
So how is this research impacting real-world applications of LLMs?
Well, imagine a customer service chatbot that's been trained to handle a wide range of inquiries. Billing questions, technical support, you name it. With continual learning, you could update that chatbot to, say, handle new product launches or policy changes, but it wouldn't forget how to address those basic customer needs.
So it's constantly learning and improving, but it retains its core knowledge.
Exactly. And that ensures a seamless and consistent customer experience, even as the business, evolves and expands.
That's a really great example of how continual learning is making LLMs more versatile, more adaptable to the changing needs of businesses. It's like having an employee who can constantly learn new skills without ever forgetting the basics.
Right. It's invaluable.
Absolutely invaluable. But beyond these technical challenges, there's also the question of, how we use LLMs in a way that's beneficial and responsible.
Absolutely. LLMs are incredibly powerful tools, and with great power comes great responsibility.
The research dives into some really exciting business applications, but it also stresses the importance of careful consideration and ethical awareness.
Right. We need to be mindful of the potential impact of these technologies on society and make sure they're being used in a way that aligns with our values.
Absolutely.
And that means being aware of potential biases in the data used to train these models and taking steps to mitigate those biases. And it also means considering the potential impact of LLMs on employment and the workforce. We need to find ways to use these technologies to create new opportunities, not just displace existing jobs.
It's a complex landscape, but it's also really, really exciting.
Yeah, for sure.
We're witnessing a technological revolution that has the potential to reshape so many industries, so many aspects of our lives.
Yeah, absolutely.
And as we navigate this, this uncharted territory, it's crucial that we have these conversations.
Yeah, we have to talk about it.
To understand both the power and the limitations of LLMs.
Right.
And to ensure that we're using them in a way that benefits humanity as a whole.
I couldn't agree more. And one of the key aspects of using LLMs responsibly and effectively is understanding prompt engineering.
Prompt engineering. We touched on that a little bit earlier, but I'd love to dig a little deeper. What exactly is prompt engineering? And why is it so crucial for unlocking the full potential of LLMs?
Think of an LLM as a highly skilled, but, kind of literal-minded assistant. It can do amazing things, but it needs clear, specific instructions.
Okay.
And prompt engineering is the art of crafting those instructions, the inputs or prompts that we give to the LLM. It's about understanding how to communicate with these AI systems to get the results that we want.
So it's like, instead of just giving it a vague idea, you're giving it a detailed recipe to follow.
Yeah. Exactly. The more specific and well-crafted your prompt is, the more likely you are to get the results you're looking for. And that's where prompt engineering strategies come in.
Okay.
These are techniques that help us structure our prompts in a way that guides the LLM's reasoning and enhances its performance.
Can you give us some examples of these prompt engineering strategies? Like, how are they being used in the real world?
Absolutely. One powerful strategy is called chain of thought prompting.
Okay.
It's based on the idea that breaking down a complex problem into smaller, more logical steps can help the LLM to reason more effectively.
So it's like you're walking it through the process step by step.
Exactly. For example, let's say you want the LLM to analyze a financial report and summarize the key findings. Instead of just giving it the whole report, you could guide it with a prompt like, first, identify the company's revenue and expenses, then calculate the profit margin. Finally, summarize the company's overall financial performance.
So it's like giving the LLM a roadmap to follow, guiding it through that analytical process.
Exactly.
Yeah.
And that can be incredibly valuable in fields like finance, law, or scientific research, where that complex reasoning is so important.
Yeah, where you really need to be able to follow the logic. What about other strategies?
Another effective strategy is keyword-based prompting, and that involves including specific keywords in the prompt to focus the LLM's attention and guide it towards generating more relevant outputs.
Okay, so you're basically giving it hints to steer it in the right direction.
Yeah, exactly. So, for example, let's say a marketing team is using an LLM to generate ad copy for a new product. By including keywords related to the product's features and the target audience, they can influence the LLM to create more targeted and effective ad copy that actually resonates with potential customers.
So it's all about giving the LLM those right cues, making sure its output aligns with the specific goals of the task. And I imagine these prompt engineering strategies are becoming even more important as businesses start using LLMs for more specialized applications.
Absolutely. As LLMs become more integrated into our work, understanding how to communicate with them effectively is going to be a key skill.
It's like learning a new language, almost.
In a way, yeah. It's about understanding how to speak the language of AI to get the best results.
This deep dive into prompt engineering has been really insightful.
It's a fascinating field, isn't it?
It is. It's clear that as LLMs continue to evolve and become more sophisticated, our ability to communicate with them effectively is going to be crucial for unlocking their full potential and making sure they're being used responsibly. But before we wrap up our exploration of LLMs for today, I'd love to get your perspective on their limitations.
Okay, yeah, good point. It's important to be realistic about what LLMs can and can't do.
Exactly. We've talked about some of the challenges in developing them, but what about their inherent limitations?
Right, well, LLMs have made incredible progress, but they're not perfect.
Of course not.
One key limitation is their lack of what we call common sense reasoning.
Oh, interesting. So they can process tons of information, generate human quality text, but they might struggle with like real world understanding.
Exactly. They don't always grasp how things work in the real world. It's kind of like they have book smarts, but not street smarts.
So they could ace a standardized test, but maybe not understand a simple joke or how to navigate a social situation.
Right. And this lack of common sense can sometimes lead to outputs that are unexpected or even nonsensical.
Okay, so we have to be careful about taking everything they generate at face value.
Exactly. We need to evaluate their outputs carefully, make sure they're logical, make sure they make sense in the real world. LLMs can be powerful tools, but they're not infallible.
That's a crucial reminder. So what other limitations should we be aware of?
Well, another significant limitation is that LLMs can be easily fooled or manipulated. They can be tricked into generating, biased or offensive content or even used to spread misinformation. And this is because they learn from the data they're trained on, and that data can contain biases or inaccuracies.
So it's like that old saying, garbage in, garbage out.
Exactly. If an LLM is trained on biased or flawed data, its outputs will reflect those biases.
This really highlights the importance of data quality, doesn't it?
Absolutely. We need to be very careful about what we feed these models. And it also underscores the need for ongoing research and development to address these limitations.
To make LLMs more robust, more reliable, and more ethical.
Exactly. We need to make sure they're being used for good.
This has been an incredible deep dive into the world of LLMs. We've covered so much, their inner workings, the challenges developers face, those exciting applications emerging across industries, the whole concept of prompt engineering, and even their inherent limitations. It's clear that LLMs are powerful tools with the potential to revolutionize so many aspects of our lives. But they also come with challenges.
It's definitely a complex landscape, but it's also incredibly exciting.
It is. And as we navigate this rapidly evolving landscape, it's crucial that we stay informed, engage in these thoughtful discussions, and ensure that we're using these technologies responsibly and ethically. But before we wrap up our deep dive for today, I'm curious to get your take on the future of LLMs.
The future of LLMs, that's a big question, but I'm happy to share my thoughts. There are so many exciting developments happening right now, and it's hard to predict exactly where things will go, but I can tell you what I'm most excited about. One trend that I think is really fascinating is the push towards even larger and more powerful models. We're seeing a race to develop LLMs with trillions of parameters.
Trillions. Wow, that's hard to even fathom.
I know. And those models are capable of handling even more complex tasks and generating even more human-like text.
So the bigger is better trend in LLMs isn't slowing down anytime soon?
Not at all. It's full speed ahead. But of course, these massive models come with their own challenges. They require huge computational resources, and there are questions about accessibility and sustainability. But alongside this push for bigger models, there's also a growing focus on efficiency.
Efficiency, okay.
Researchers are exploring new techniques to reduce the computational cost of training and running these LLMs so they're more practical to use and accessible to more people.
It sounds like a balancing act, pushing the boundaries of model size while also making them more efficient and sustainable.
Yeah.
What are some of the specific approaches you're seeing in that area?
Well, one really promising avenue is the development of specialized hardware for AI.
Okay, so like custom-built chips.
Exactly. These chips and processors are optimized for the kinds of calculations that LLMs need. They allow for faster processing and lower energy consumption. And we're also seeing a lot of progress in distributed computing.
Distributed computing, so spreading the workload across multiple machines.
Exactly. And that allows for faster training and the ability to handle even larger models. It's really fascinating to see how these different areas, software, hardware, computing, are all converging to drive the evolution of LLMs.
It's like all these pieces are coming together to create something truly extraordinary. And you mentioned earlier that along with these efforts to scale up and streamline LLMs, there's also a growing trend towards specialization, right?
Yes.
What does that mean exactly?
Specialization refers to the development of LLMs that are tailored for specific tasks or specific industries. We're already seeing this in fields like healthcare, finance, law. These specialized models are trained on data that's really relevant to their domain, so they can be much more accurate and perform very specialized tasks.
So it's like having a team of experts, each with deep knowledge in their area.
Exactly.
That makes a lot of sense. This specialization seems like a natural progression as LLMs become more widely used. What other exciting trends are you seeing out there?
One area that I'm particularly excited about is multimodal LLMs.
Multimodal, so not just text.
Right. Right now, most LLMs are mainly focused on text. But imagine an LLM that can seamlessly work with text, images, audio, and video.
Wow. That's like taking LLMs from just language to the whole realm of human experience.
It is, and it opens up so many possibilities.
Give us some examples. Like, what could we do with those kinds of LLMs?
Well, imagine an e-commerce platform that uses a multimodal LLM to analyze product photos and customer reviews and then automatically generate descriptions in multiple languages.
Okay, that's pretty cool.
Or a healthcare provider that uses a multimodal LLM to analyze medical images and patient records and then provide personalized treatment recommendations.
That's incredible. It seems like these multimodal LLMs could revolutionize so many fields.
I think so too. We're really on the cusp of a new era of human-computer interaction.
It's mind-boggling to think about the possibilities. But with all this power comes responsibility, right?
Yeah.
How are developers addressing the ethical considerations of all these advancements?
That's a crucial point. The AI community is definitely grappling with the ethical implications. One major focus is mitigating bias.
Bias, right. We've talked about how LLMs can inherit bias from the data they're trained on.
Exactly. And that can lead to all sorts of unfair or discriminatory outcomes. So researchers are working on techniques to detect and mitigate bias in training data and make these models more transparent and accountable.
So it's not enough to just make them smarter, we also have to make them fairer.
Right. And another key area is privacy and data security. These models often process really sensitive information, so it's crucial to have safeguards in place. And there are also discussions around the impact of LLMs on employment. We need to make sure they're creating new opportunities, not just replacing jobs.
It sounds like a really...
It is, and it raises a lot of important questions, but it's exciting to see how much progress is being made.
It really is. And speaking of progress, you mentioned earlier that along with these efforts to scale up and streamline LLMs, there's also a growing trend towards specialization, right?
Yes, absolutely. Specialization is a key trend to watch. It refers to the development of LLMs that are specifically designed for certain tasks or industries.
Okay, so we're talking about LLMs that are experts in their field.
Exactly. And we're already starting to see this happen in areas like healthcare, finance, law, you name it. These specialized models are trained on data that's really relevant to their domain, so they can be much more accurate and perform very specialized tasks.
So it's kind of like having a team of specialists, each one with deep knowledge in a specific area.
That's a great analogy. For example, imagine a healthcare-specific LLM. It could be trained on medical texts, patient records, research papers, all that good stuff. And that would make it an expert at understanding medical terminology, identifying potential diagnoses, or even assisting with drug discovery.
Wow, that's incredible. It really seems like this specialization is a natural next step as LLMs become more integrated into different industries. It's like, the more we use them, the more specialized they need to become.
Exactly, and it's happening really fast.
This is all so fascinating. But before we get too carried away with all the exciting possibilities, let's circle back to some of the challenges that we touched on earlier, specifically the limitations of LLMs. We've talked about some of the difficulties in developing them, but what about their inherent limitations? What are some things that they just can't do no matter how advanced they become?
That's a really important question. It's easy to get caught up in the hype, but it's crucial to be realistic about what LLMs can and can't do. While they've made incredible strides in recent years, they're not a magic bullet. They still have limitations that we need to be mindful of.
Okay, so let's talk about those limitations. What are some of the key things that we need to keep in mind?
Well, one of the biggest limitations is their lack of what we call common sense reasoning.
Common sense. So are you saying that they can process all this information, generate human quality text, but they might struggle with understanding basic everyday things?
That's exactly it. They don't always grasp how things work in the real world. It's almost like they have book smarts, but not street smarts.
So they could ace a standardized test, but might not understand a simple joke or know how to navigate a social situation.
Precisely. And this lack of common sense can sometimes lead to outputs that are unexpected, nonsensical, or even inappropriate. For example, an LLM might be able to write a grammatically perfect sentence about a cat flying, but it wouldn't understand that that's physically impossible.
Right, because it doesn't have that real-world context.
Exactly. So while LLMs can be incredibly powerful tools, we need to use them with a critical eye and recognize that their outputs might not always be grounded in real-world understanding.
So we can't just blindly accept everything they generate. We have to evaluate it carefully.
Exactly. We have to make sure that it makes sense, that it's logical, and that it aligns with our own understanding of the world.
That's a really important point.
Yeah.
So lack of common sense, that's one big limitation. What are some others?
Another significant limitation is that LLMs can be easily fooled or manipulated. They can be tricked into generating biased or offensive content, or even used to spread misinformation. And this is because they're trained on massive amounts of data, and that data can contain biases, inaccuracies, or even outright falsehoods.
So it's that old saying, garbage in, garbage out.
Exactly. If you train an LLM on biased or flawed data, its outputs will reflect those flaws. This highlights the critical importance of data quality and the need to be very careful about what we feed these models. It also underscores the need for ongoing research to address these limitations and make LLMs more robust, reliable, and ethical.
So it's not just about making them more intelligent, it's about making them more responsible.
Absolutely. We need to ensure that they're being used for good, not for harm.
That makes perfect sense. So we talked about some of the limitations of LLMs, but I want to shift gears a bit and talk about the future. What are some of the key trends and developments that you're most excited about in the world of LLMs? What can we look forward to in the coming years?
Oh, there are so many exciting things happening right now. It's hard to even know where to begin. But one trend that I think is particularly fascinating is the push towards even larger and more powerful models. We're literally seeing a race to develop LLMs with trillions of parameters.
Trillions. Wow. That's just mind-boggling.
It is, and these models are going to be capable of handling even more complex tasks and generating even more human-like text than anything we've seen before. It's really pushing the boundaries of what's possible with AI.
So the bigger is better trend in LLMs isn't slowing down anytime soon.
Not at all. It's full steam ahead. But of course, these massive models come with their own set of challenges. They require enormous computational resources, and that raises questions about accessibility and sustainability.
Right. Not everyone has access to those kinds of resources.
Exactly. And that's why, alongside the push for bigger models, there's also a growing focus on efficiency. Researchers are exploring new techniques to reduce the computational cost of training and running these LLMs, making them more practical and accessible to a wider range of users.
So it's kind of a balancing act, pushing the boundaries of model size while simultaneously trying to make them more efficient and sustainable.
Precisely. It's a delicate balance, But it's crucial to find that sweet spot if we want to make this technology truly transformative.
What are some of the specific approaches being explored to achieve that balance?
Well, one really promising avenue is the development of specialized hardware designed specifically for AI workloads. These new chips and processors are optimized for the kinds of calculations involved in training and running LLMs, enabling faster processing and lower energy consumption.
So it's not just about software advancements, it's also about hardware innovation.
Exactly. And we're also seeing a lot of progress in distributed computing, where the workload of training an LLM is spread across multiple machines. This allows for faster training times and the ability to handle even larger models. It's really exciting to see how these different areas, software, hardware, computing, are all converging to drive the evolution of LLMs.
It really is. It's like all these pieces are coming together to create something truly extraordinary. Now, you mentioned earlier that in addition to scaling up and streamlining LLMs, there's also a growing trend towards specialization, right?
Yes, absolutely. Specialization is a key trend to watch. It refers to the development of LLMs that are tailored for specific tasks or industries.
Okay, so we're talking about LLMs that are experts in their field.
Exactly. And we're already seeing this happen in areas like healthcare, finance, law, you name it. These specialized models are trained on data that's really relevant to their domain, so they can be much more accurate and perform very specialized tasks.
Can you give us an example of what that might look like in practice?
Sure. Imagine a healthcare-specific LLM. It could be trained on medical texts, patient records, research papers, all that good stuff, and that would make it an expert at understanding medical terminology, identifying potential diagnoses, or even assisting with drug discovery.
Wow, that's incredible. It seems like this specialization is a natural next step as LLMs become more integrated into different industries.
Exactly. And it's happening really fast. The more we use LLMs, the more specialized they need to become to meet the specific needs of different fields.
This is also fascinating. What other exciting trends are you seeing emerge in the world of LLMs?
One area that I'm personally really excited about is multimodal LLMs.
Multimodal. So not just text.
Right. Right now, most LLMs are primarily focused on text. But imagine an LLM that can seamlessly integrate text, images, audio, and video. This would open up a whole new world of possibilities.
That sounds incredible. It's like taking LLMs from the realm of language to the realm of human experience.
Exactly. And it has the potential to revolutionize so many industries.
Can you give us some examples of what these multimodal LLMs might be able to do?
Sure. Imagine an e-commerce platform that uses a multimodal LLM to analyze product photos and customer reviews, and then automatically generates detailed product descriptions in multiple languages. Or a healthcare provider that uses a multimodal LLM to analyze medical images and patient records, and then provides personalized treatment recommendations. The possibilities are truly transformative, and they span across industries like education, entertainment, and even scientific research.
Wow. It's mind-boggling to think about the potential impact of these multimodal LLMs. It seems like we're really on the cusp of a new era of human-computer interaction, where AI systems can understand and respond to the world in a much richer and more nuanced way. But as we push the boundaries of what's possible with these increasingly powerful AI systems, it's crucial that we don't lose sight of the ethical considerations. How are researchers and developers addressing these concerns as they continue to advance the field of LLMs?
That's an incredibly important point. The AI community is actively grappling with the ethical implications of LLMs. One major focus is on mitigating bias. As we've discussed, LLMs can inherit biases from the data they're trained on, and this can lead to unfair or discriminatory outcomes. So researchers are developing techniques to detect and mitigate bias in training data and to make LLMs more transparent and accountable.
So it's not just about making them more intelligent, it's also about making them more fair and equitable.
Exactly. And another key area is privacy and data security. These models often process very sensitive information, so it's crucial to have strong safeguards in place to protect that information from misuse or unauthorized access. We're also seeing a lot of discussion around the potential impact of LLMs on employment and the need to ensure that these technologies are used to create new opportunities and enhance human capabilities rather than displace jobs.
It seems like the development and deployment of LLMs require a very careful and considered approach, one that takes into account not just the technological advancements, but also the ethical, social, and economic implications. It's a complex and multifaceted challenge, but it's essential that we have these conversations and work together to shape the future of AI in a way that benefits humanity as a whole.
I couldn't agree more. The future of LLMs is bright. And it's up to all of us to ensure that it's a future that we can all be proud of.
This deep dive has been an incredible journey. We've covered so much ground from the foundational concepts of LLMs to the cutting-edge research that's shaping their future. It's clear that we're living in a time of extraordinary technological change, and LLMs are at the forefront of this revolution.
It's truly a remarkable time to be working in this field. The pace of innovation is simply astounding.
I feel inspired and a little bit overwhelmed by all the possibilities, but also empowered to approach this new era with a sense of informed optimism.
That's exactly the spirit we need. The future of LLMs is full of promise, and it's up to all of us to ensure that it's a future that benefits all of humanity.
Thank you so much for guiding us through this fascinating deep dive. It's been an absolute pleasure learning from you.
The pleasure was all mine. And to all our listeners, thank you for joining us on this exploration of large language models. We hope you found it as insightful and thought-provoking as we did. Until next time, keep learning, keep exploring, and keep asking questions. It really is a complex landscape. But yeah, it's exciting to see how much progress is being made in thinking about those things.
It really is. And speaking of progress, you mentioned earlier that along with these efforts to scale up and streamline LLMs, there's also a growing trend towards specialization, right?
Yes, absolutely. Specialization is a key trend to watch. It refers to the development of LLMs that are specifically designed for certain tasks or industries.
Okay, so we're talking about LLMs that are like experts in their field.
Exactly. And we're already starting to see this happen in areas like healthcare, finance, law, you name it. These specialized models are trained on data that's really relevant to their domain, so they can be much more accurate and perform very specialized tasks.
So it's kind of like having a team of specialists, each one with deep knowledge in a specific area.
That's a great analogy. For example, imagine a healthcare-specific LLM. It could be trained on medical texts, patient records, research papers, all that good stuff. And that would make it an expert at understanding medical terminology, identifying potential diagnoses, or even assisting with drug discovery.
Wow, that's incredible. It really seems like this specialization is a natural next step as LLMs become more integrated into different industries. It's like, the more we use them, the more specialized they need to become.
Exactly, and it's happening really fast.
This is all so fascinating. But before we get too carried away with all the exciting possibilities, let's circle back to some of the challenges that we touched on earlier. Specifically, the limitations of LLMs. We've talked about some of the difficulties in developing them, but what about their inherent limitations? What are some things that they just can't do no matter how advanced they become?
That's a really important question. It's easy to get caught up in the hype, but it's crucial to be realistic about what LLMs can and can't do. While they've made incredible strides in recent years, they're not a magic bullet. They still have limitations that we need to be mindful of.
Okay, so let's talk about those limitations. What are some of the key things that we need to keep in mind?
Well, one of the biggest limitations is their lack of what we call common sense reasoning.
Common sense. So are you saying that they can process all this information, generate human quality text, but they might struggle with understanding basic everyday things?
That's exactly it. They don't always grasp how things work in the real world. It's almost like they have book smarts, but not street smarts.
So they could ace a standardized test, but maybe not understand a simple joke or how to navigate a social situation.
Precisely. And this lack of common sense can sometimes lead to outputs that are unexpected, nonsensical, or even inappropriate. For example, an LLM might be able to write a grammatically perfect sentence about a cat flying, but it wouldn't understand that that's physically impossible.
Right, because it doesn't have that real-world context.
Exactly. So while LLMs can be incredibly powerful tools, we need to use them with a critical eye and recognize that their outputs might not always be grounded in real-world understanding.
So we can't just blindly accept everything they generate. We have to evaluate it carefully.
Exactly. We have to make sure that it makes sense, that it's logical, and that it aligns with our own understanding of the world.
That's a really important point. So lack of common sense, that's one big limitation. What are some others?
Another significant limitation is that LLMs can be easily fooled or manipulated. They can be tricked into generating, biased or offensive content, or even used to spread misinformation. And this is because they're trained on massive amounts of data, and that data can contain biases, inaccuracies, or even outright falsehoods.
So it's that old saying, garbage in, garbage out.
Exactly. If you train an LLM on biased or flawed data, its outputs will reflect those flaws. This highlights the critical importance of data quality and the need to be very careful about what we feed these models. It also underscores the need for ongoing research to address these limitations and make LLMs more robust, reliable, and ethical.
So it's not just about making them more intelligent, it's about making them more responsible.
Absolutely. We need to ensure that they're being used for good, not for harm.
This has been such an incredible deep dive into the world of LLMs. We've covered so much ground, from the basic concepts to the cutting-edge advancements. It's clear that LLMs are already transforming the way we interact with information, and they have the potential to revolutionize countless industries in the years to come.
I completely agree, and it's been an absolute pleasure discussing all of this with you.
The pleasure was all mine. And to all our listeners, thank you for joining us on this journey into the fascinating world of LLMs. We hope this deep dive has given you a better understanding of these powerful tools and the incredible impact they're having on our world. We encourage you to continue learning, exploring, and engaging in these important conversations about the future of AI. Until next time, keep those questions coming.